In this video, I'm going to show you how to do a t-test, and we are going to do a t-test to look at to see if there's a difference between the resiliency scores of traditional students and non-traditional students. So the first thing I want you to do is create another tab. Click on the add sign, and it'll pop up a sheet number, whatever. Then double click on it and call it t-test. So you have a t-test tab. I'm going to go back to the data. I want you to select the whole thing. Actually, if you go up here, just click on the very corner and then copy. That we don't have to highlight the whole thing because there's a lot of data to find. Click on t-test, click in the first box, and paste. Now what we want to do is we want to go over here to the resiliency total, this column. Oops, we could have copied just over the resiliency total, but what we want to do is we want to separate the age groups. So we want to separate the 2s and the 3s from the 1s, because we want to see the one is age 18 to 25 and the other ones are 26 and above. So we want to see, is there a difference in the resiliency scores for those individuals who are 18 to 25 versus those who are 25 and above. So to get this in order, what we want to do is click on this, and we want to go to data. Let's see which one it is again, sorry. Sometimes I haven't used it for a while. It takes, oops, there it was. So go to the data. There we go, data tab. And on the data tab, you have sort. And we want to sort smallest to the largest. So click on that after you highlight this row. Go to the data tab. And then it'll give you this pop-up window that says Microsoft Excel found data next to your selection. Since you have not selected this data, it will not be sorted. What do you want to do? You want to expand your selection, expand the selection so that we get all the information, because we want not just the ages, we want the total resilience scores and the age to still be in the same. If I don't, I'll show you what happens. If I just do the current selection, now pay attention to the resiliency scores over here. 148 is now matched with somebody who is a 36 and above. But if I sort it without expanding the selection, now I have 148 that is now associated with somebody who's 18 to 24. So I don't want to do that. I want to expand my selection. So again, click on the whole row, sort, expand the selection, and sort. So now we have the one. This person has a resiliency total of 113, and they are 18 to 25 years old. So we wanted to make sure they all are the same. So if you scoot over here now, you're going to see your ID numbers all have changed. They're not in order that you had them before, because we want to separate out those who are young from those who are traditional students, I should say. Separate them from those who are 25, 26 and above. Now, to do our t-test, he showed you one way in the video earlier, but I'm going to use the data analysis tab because it gives us more information. So click on data analysis. Make sure that you're in the data tab, because that data analysis does not show up unless you're in the data tab. Go to t-test. This is a 2 sample, and we're assuming they are of equal variance, that they vary approximately the same. And click OK. It's going to ask you for the input range for variable number 1. And that is, so this, we're looking for the resiliency scores. So you want all the ones who have 1. So I'm going to select all the ones who fit into the category of 18 to 25. Then the range 2 is going to be all the ones who fit in to a 2. So this one all the way down. The hypothesized difference, I'm going to put 0.05 because that's what we normally use in social sciences. I didn't use labels, so don't check labels. And then output range, I'm going to choose a place. Let's choose down here someplace. Oops. Stop it. Right here. Let's put the output range right there and then click OK. Now we can't see that very well. And since Excel wouldn't let me go further over to find more space, I'm going to just play with it here. So double click on the line to give you more visuals of what you're looking at. There's a lot of numbers here, so I think if you remember, we could go back to home and get rid of some of these decimal points. Highlight them. I want to get rid of some decimal points. I want a few more than, let's go with 3. And same with these ones over here. There's too many decimal points. Okay, so now what is this saying to us? Well, now we can look at the mean for variable 1, which is the 18 to 24-year-olds. Their mean score on the resiliency scale was 134. On variable 2, which was the 26 and above, their mean score is 141. So their score is, for the resilience, is slightly higher for the individuals who are 26 and above. We had 8 people, 8 observations, so 8 participants that were 18 to 25. We had 23 that were 26 and above. These ones you don't really have to worry about. We just hypothesized the mean difference of being 0.05. Degrees of freedom, this is something you have to address when you're writing out the results. So the degrees of freedom is the variable, the number of participants in this group plus the number of participants in that group minus 2. And the reason we do degrees of freedom is so that we can more accurately report our numbers. We'd rather report low than over-exaggerate and have inaccurate results. The t-stat, that is your t-score. So this is the t-score that you get. So it's negative 1.117. And if you remember, that is a score that you go into the table and say, is this number higher or lower than the critical value? So here's your t-stat. So for a one-tail, look at the critical value for one-tail. I'm going to highlight this for a second so you can see. So keep that one in mind. That's our t number, t-score. And here is for a one-tail hypothesis, meaning that I said there is going to be a significant, there's individuals who are 18 to 25 will have significantly lower scores. That's my hypothesis, would be that they have lower resilience. I'll have to say, is my hypothesis correct? So that's a one-tail, that's going in a direction. So my t-stat is 1.17 and my critical one-tail is 1.69. So my critical value is higher than my t-stat, which means I have to accept the null. And here is your p-value. This is another way to see that whether you can accept or reject the null. So if we set we want to be p is 0.05 or less. Here we have 0.13. So that is higher than 0.05, which means we have to accept the null. If it's a two-tail, this is the critical value for two-tail, and you can see it's significantly higher. 2 is much higher than negative 1.117. So again, we have to accept the null and reject the alternative hypothesis that we had. And so that is the quickest way to do a t-test, and with all these different numbers. Look forward to seeing what you guys come up with on your t-test, those of you who are running t-tests.